Today we are going to discuss salient pole synchronous generator. So, as you know that in case of salient pole synchronous generator, what is special in that is like the rotor structure. Unlike the cylindrical rotor, the rotor structure is not uh, even in shape. Rather, the rotor is having projected poles. So how having that projected poles can affect our means machine performance? In order to understand that, let me draw, or better to say, let me just take help of a few pictures that will help you to understand the rotor means issue here. Like, try to understand one thing, that here you are having this kind of even shaped stator. Well, just a minute. So this is our stator. We can just this is our stator one, right? Now we can have, in case of cylindrical rotor, what we have? We have another cylindrical structure inside it, and it is like having, so it gives you a clear understanding that although the due to my poor drawing skill, it may gives you a feelings that these are not like continuous, or when you can figure out that there is an even air gap we can see here. But in case of projected pole system, what happens? Just a minute. Probably this. Yeah. Now, in case of projected pole, what we have, suppose if you have a two-pole machine, the machine structure would be like this. Well, so what you will figure out that, unlike in case of your normal cylindrical rotor machine, here it will have an uneven air gap. Like if you consider this is your direct axis, and this side is your quadrature axis, you can see that this is your direct axis. Now what you will see that you are having the stator coils evenly placed on this, but the stator coils that are in the vicinity of direct axis, like here whatever stator coils you are having in this region, right, and in this region whatever MMF they are producing, this MMF is facing a shorter air gap, and if you consider here this side, they are these sides are quadrature axis component. This side armature windings MMF are facing appreciable amount of larger air gap. It's a very means tangible difference exists between the air gap. Try to understand one thing, that is from you will not find it in any book, but if you do not understand this basic, then your understanding will remain incomplete. So until unless you load them, there will be no armature reaction MMF, and all this will not come in picture. Right? So until unless there is and also what you can write is that now with this understanding, let us proceed to derivation of our Phasor diagram. Like now, if we try to extend that what we did for our cylindrical rotor machine, like construction of Phasor diagram using EMF method, then what we will see that in EMF method there was something like means even if we try to represent armature reaction by means of a drop across reactance part, which we called as armature reaction reactance, it was a single valued reactance. But here, because your armature reaction means like two portion of armature circuits, they are experiencing two different value of reluctances. So first understanding should be that one constant reactance, armature reaction reactance, is insufficient to represent armature reaction in this case. So what suggestion came? The suggestion came from Andre Blondel. So that Andre Blondel, I just forgot the year in which he just developed it, probably in 19 like the first decade of 20th century he did it. In between 1902 to 1910, it was that first decade of 20th century. So what he did is that it was very interesting that he suggested something that is known as two reaction theory. Like instead of one armature reaction, let us consider two reaction theory. This is the same gentleman who is responsible for measuring power for means measuring three-phase power using 2 watt meter method. So that gentleman has probably is quite means close to 2 means the number 2. That is why he proposed two reaction theory here. Anyway, let us keep that jokes apart. The reason behind two reaction theory is that two different reluctance we can observe, or rather we can intuitively uh, understand that two different reluctance will exist in this circuit. So two reactance theory. That is, it's not that he was very fascinated or he was having some prejudice with number 2. It was, that is why it was 2. Now what we can write, like for if you can recall the MMF equation for armature, the MMF equation is something like this is the total armature reaction. This is obviously for the current. Now see, obviously for, you can say it's for primary current also. You can means sorry, not primary, like fundamental current. For other higher order harmonics, you will get means you have to evaluate kW. We all know that kW has to be evaluated for different cases. Now what we can write, that is very interesting to note, that how to make you understand. Well, let me show you something, or rather let me try to draw something for you. I know I am not good at drawing, but I hope that would help. Or just let me just take a snap and share it here. So as I said, I have taken these snaps from some book. So what it shows, the first one is for direct current MMF, the second one is for quadrature MMF, and third one is for due to field MMF. So what I would like to first write a few equations that, if you have well acquainted with the previous derivation of fundamental of rotating machine, you should surely be able to recall and recollect it, that AD is 2 root 2 pi into, for 3-phase it would be like so. Why this is beta is coming? This beta, what is this beta? Beta, you can say that beta is an angle that is between like if this is my quadrature axis and this is my direct axis, this one is my direct MMF, or F is acting along this. This is my D axis or direct axis. This is my Q axis. I am assuming my current is making an angle. This is I, the armature current, that is making an angle beta with this. So in that case, what we are having here, we are having this one is your cost component, that is denoted by AQ, and this one is your sine component, that is denoted by AD. So obviously that AD will be something like, now if you want to take a per phase approximation, then obviously you need to drop this factor 3. This is due to the number of phase. Similarly, AQ will be 2 root 2 pi now. Try to understand that these both of these armature reaction MMF is produced by two virtual current. There is no physical current of such magnitude does exist in reality, or do exist in reality. But what happened here in reality is that if we consider the actual, or try to directly means address the actual case where we are having a single MMF, but that single MMF or reaction MMF, but that single reaction MMF is experiencing variation of reluctance due to unevenness of rotor structure. So we will never be able to address that. So in order to cope up with that, what we need to do is that it's very simple thing. We have splitted them into, means we have rather we have expressed them into different orthogonal component. One is along our direct axis or field axis, as you can see that AD, and the other one is AQ. Now why this AD and AQ, that makes difference, like this picture is also a good one. Like you can see that AD AQ MMF, this is drawn in scale. It is to make you or means give you more like better understanding in this. Here you can see that this AD on is acting on pole phase. So what is happening here, that this AD is actually like it is means the BAD that is produced by this direct armature reaction is quite dominant in nature. But here when you are looking for this one, you can see that this is producing a BAQ. Why? Because if you can recall, it is always B is equal to mu into H, and H you can get by means dividing your A by the amount of length. A is in the unit of MMF, that is ampere turn. When you divide this by length, then you will get H, and that H, when you will try to figure out that with that H, you should get something that is responsible for your B, the flux density. Now that flux density over that, now flux density exists where? Flux density exists in that region between your stator and rotor. Now obviously if you consider an uneven rotor structure with projected poles, so means under the pole shoes, whatever air gap you will face, and in the quadrature region, the pole or means that interpolar region, you will face a very high amount of reluctance. So therefore your actual difference will come in terms of your B. That is why it is shown that BAD and BAQ are two different. But at the same time, try to remember that if we directly just try to extend that what was there in our means reluctance method, sorry, not reactance phasor, sorry, in our EMF method, you will see that we are trying to figure out for each and every MMF, we are trying to figure out a corresponding EMF. That is based on linear circuit linear magnetic circuit assumption. However, basically it is not the MMF, rather the means obviously MMF, but at the same time, in case of variable reluctance, it would be better to say that it is the flux density that makes the impact, not the actual MMF, rather the flux density with which your things are proportional. Now, for these two different flux densities like BAD and BAQ, you are likely means you can expect that you will have two different value of EMF induced, means if you try to represent them by two different means reactance in electrical equivalent circuit, then you should have two different reactance representation for them. Basically, in a single sentence, I can say you need two different armature reaction reactance to represent them, and that is why it is known as Blondel two-reaction theory. Coming to the construction of phasor diagram, what is required here is that if we consider the like, let us assume at the very beginning that we know all the representation in the sense that like we know that the voltage drop due to the fluxes, like obviously we are assuming we are having two currents, and in addition what we are assuming that their voltage drop are like two fluxes in armature winding will be like their corresponding voltage drop is like then here it is like correct. Now see that like what we will have here that these two fluxes, interestingly, they are just like JIAXAS, means armature reaction reactance. They do not include the leakage part. So what we will get, the terminal voltage is equal to what we can write like terminal voltage plus all the drops that will give you what? Induced voltage. Now this is another interesting thing, that induced voltage across armature winding is due to a field that is always experiencing an even magnetic path that I mentioned earlier. That field, when field from field structure, if you sit on a field pole, what you see, you will see, and you are rotating inside, and means inside a hollow cylinder. It is perfectly, means your distance from cylinder inner wall will always remain constant. So now, if you are kind of, if you consider yourself as a magnetic pole that is either inventing or means acting as a magnetic source or magnetic sink, whatever you be, you will see that your distance, or means the whatever magnetic circuit you are, means from your perception, it appears to you as an evenly means as a constant thing. So that is why when you are trying to means induce a voltage as per your means, or try to cause voltage induced across armature circuit, it will always be that means as per your ability, right? Sorry, here I should write induced voltage during open circuit condition, right? Now, so here what we can write is that E naught is equal to, that is open circuit induced voltage, is equal to terminal voltage plus I into, remember armature circuit is a single circuit, so armature means I am writing per phase. Now there will be single leakage, so plus J I A Q X A Q plus J I A D X A D. So unlike the cylindrical rotor, which was having here J I X A S, here we are considering two components with their two component of current, right? Now what we can write further, that is interesting, that I is equal to, Phasor sum of I is equal to IAQ plus IAD. Just let me check whether I wrote okay, IDIQ. So let us be consistent with that form. So let me make a correction here. It is ID. Okay. Well, we are here. Now what we can write further, that if we consider it in such a manner, we can further simplify this one in this way. And this xq is equal to like instead of having one armature reaction reactance, here we are having two armature reaction reactance, and we are having two like synchronous reactance. Previously we were having one for cylindrical rotor machine, now we are having two. So you may take your time to understand this, that This is the splitting we have done here, that from I we got IQ XL. So we club that. So let me write more clearly. XQ is equal to XL say Q. So now based on this equation, let us construct the phasor diagram. So, oh God, oh God. Yeah, that is the problem with copying something. You sometimes make mistakes, and that mistakes sometimes become fatal, but funny yet. Anyway, so back to business. We are having these four components. We need to represent them. So I would like to start with this one. Well, this one. Let us go to next page. In the beginning, I am assuming that we know what are the knowledges we are having here. Knowledge we are having here, it is that knowledge of XAD, knowledge of XAQ, and also knowledge about XL, and also obviously we know beta. In addition, we know means other things we can measure like VI and also power factor. Those are measurable from our available instruments. So these four are known to us. Then we are ready for construction of phasor diagram. Please pay your attention. So what we can do here is that let me see whether there is any. This is our V. Well, then let us add. Obviously you cannot see anything right now, but gradually you will be able to see. What is the problem here? This is my eye, that is making an angle theta with this. Then let us draw IR. I do not understand what is wrong with this. Array yaar. क्या हो रहा? Yeah. Well, then the next man is this one. Well, then this one is this. This is our common construction. So let me make them clear. It is B, IR, then JXL, right? Now here here we are having this is our E1 V, this is I, this is IRA, JIXL. Now as I have mentioned here that I know beta, right? I know this beta. So if I know beta, then what I can do here is that after knowing beta, I can break it in two components. One is that is I, this all. So and accordingly we need another one. So what is we are doing here? Let me draw. This is my ID sine beta, and this one is IQ, this one is ID, this is I, this is acting in this direction, this much is theta, this is the angle beta, this is 90 minus beta, got it? And here this is our E naught. Now interesting thing you have to note that what we can do is that we can exploit the second equation. What was that second equation? Is this one, right? Let me paste this second equation. Well, so if this is the case, then see the second equation says, oh god, here I have again missed the mistake. It must be x cube. Well, so what this said, we just need to add these two factors with IRA. So let us try to add them. So obviously JIQ that should lead this IQ by an angle of 90 degree, and that is with ID that should lead JIDXT that should lead this phasor by an angle 90 degree. So this is our JIDXD, and this is our JIQXQ. Mind it, it is not XAQ, it is XQ. Now the thing is that problem is, if you do not know beta, this construction depends on beta. Now knowing beta is not that easy. XAQ or XDXQ that you can evaluate using by conduction of experiment, you can figure it out. But knowing beta is not that easy, because beta is the angle between your E naught and your I. So obviously it is not an easy task for you to determine that beta. So how to address that particular issue? Well, we can do this without knowing beta. Let me show you how. It is an easy thing for us to do. Like let us just extend this line of JIXL, and also use some like letters to have an idea. O, C, then let it be A. Now drop a perpendicular on this line of JIDXT, let it be B. Then let it be D, and this one be E. So now you consider this triangle that is this much. Do not know what happened. Anyway, it's not working. So this is the triangle I am trying to make you understand. Now see, in this triangle, if you consider what is your AB, this AB is by construction, this AB is equal to JIQXQ, right? Now if this is JIQXQ, what is this side? From this triangle, what you can write, that CA is equal to AB by your cos angle from this right angle triangle, cos angle CAB, that is fine. CAB means this angle, right? Now see what is happening here. It is like this side we are not sure about this side. What is this CA? But we are sure of AB. AB is JIQXQ. Now what is C angle CAB? This angle we need to know. What we can do is that we can just extend this line to form a bigger triangle. Let it be P. So this be 90 degree. This is quite logical because you know JIXL was already making an angle 90 degree with phasor I. So this is 90 degree. So if this is 90 degree, then obviously this much is 90 minus beta from triangle law. Sum of three angles should be 180 degrees. So this is 90 minus beta. Therefore this is beta. Now if this is beta, then what we can write, that CA is equal to AB by angle CAB is equal to, forget about J, IQXQ by cosine beta. Now see that this cosine beta is equal to what? IQ is equal to I cosine beta. Therefore, if you do it, you will get, it is IXQ. So if this is IXQ, then what is the understanding here is that why we are doing all this mambo jumbo, just to avoid an explicit knowledge of beta. We may not may not be available to us. So in order to avoid this, we are doing it. Now as I said, XQ may be known to us a priori. So I we can know, and then we can join IRA with this one. This side is this side. So if you are interested in constructing phasor diagram, nowadays also phasor diagram doesn't make much sense, but it was somewhat early date. So you will find this is V, then IRA, then you join JIXQ, then you will get a point. This point is also very important. This is known as E dash, or you can say E naught dash. So what is the physical interpretation of E naught dash? I am going to discuss it soon. But once you got this E naught dash, you find this angle beta, because E naught dash is the tip of JIXQ join with O, that gives you beta. Then from that beta you can figure out the magnitude of ID IQ, because using that relation IQ is equal to I cos beta and ID is equal to I sin beta. Then you again add this JIDXT and JIQXQ to figure out that E naught, this cyan color E naught, right? So it is interesting to note that first of all, it is very interesting to note that I cannot move my what's happening here. I cannot move my cursor. Cannot move my screen. It is somewhat hanging, but give me a minute. Well, now it is working finally. So what I was discussing about, that this is for unsaturated case. Obviously for saturation we cannot draw even, we cannot even think of phasor diagram, because saturation leads a nonlinearity. But still, as I said earlier, that piecewise nonlinear means piecewise linear type nonlinear system, piecewise linear type nonlinear system can also be treated like a linear system for piecewise analysis. So here it is the case. Anyway, before I move to the next part for saturated generator, I would like to do a few more mathematical manipulation with this. Here, one thing we should not be should not avoid, or rather we should not overlook here, is that this angle delta is our power angle or load angle, right? This is very important thing here. However, for a given load, how can we measure this power angle or load angle? See here, this E0, what we can write, this E0 dash is equal to, we can write, please don't get E0 dash is equal to, we can write V plus I. Here E0 dash is equal to V plus I R A, or you can drop A here, just IR plus JXQ, right? Well, so if that is the case, then this can further be simplified like this E0 dash, then be written like, we can break it component wise. One component is along this cos delta, that is V. So we can write E0 dash cos delta plus J sin delta is equal to V plus V. We can also write it like 1 plus J0 plus I, it is cos theta minus J sin theta into R plus JXQ. Well, let me so with this, here what you can do is that once you write this equation, things become very easy for you, as they are the means complex equation. So let us equate the imaginary and uh, real part. So from that we can get tan delta, that is equal to E0 dash sin delta by E0 dash cos delta is equal to so this is also one of the most important formula here, because we can utilize this formula to figure out the delta. And once you get to know what happened, once you get to know delta, then what is beta, that is delta plus theta is your beta. So either way you can say proceed in the way that I discussed, or beforehand you can calculate it, because we are assuming xq and uh, xq and r are known to us a priori before connecting a load. And once you connect a load, you can easily measure the load power factor theta and also terminal voltage and current. So from that you can figure out the power angle. This power angle is very important. At the beginning, what problem I discussed, that beta is not known to us a priori, because beta is a machine internal thing. By means of physical means, you cannot insert or cannot connect any physical device to measure that angle beta. So that was the main difficulties we could face while drawing the phasor diagram. But then two way we can circumvent that problem. One is that first you draw IR, then JIXQ, and then go for it by constructing this, and then you can get the rest of the things done by calculating these values. Or else what you can do is that you can directly calculate, means I think this one, the second one, that is finding out delta and then finding out beta and then go for direct construction. Like otherwise again you will be in, like means how the first approach is like first you need to construct E naught dash, then you need to again construct or draw the line JID, XD, JIQ, all this. So these are the way you can do it, and this is very important formula. You should not forget this one. This is means you should try to memorize it. This will turn out to be very handy. And what modification should we need to carry out if we are considering a saturated generator? As I said, that saturation is also a kind of, you can say that it is a another linear system with different value of slope. So once you entered in the saturation region completely, what means for that limited region of operation, what phasor diagram do you expect for means hold good for this machine? That you please let me know. Well, now let us do some more mathematics, because mathematics is very important. Oh God, I do not know what is its problem. Why Without invitation, why it comes so many times? So let me just draw it that once again. Well, this is our B. Then let us draw I. Well, draw IR. Then let us draw IXL. Well, then let us draw our say we know that, so if we know IDXT, say जाओ भाई। Just a minute. Right, then you are having ID, and with that you can have your well now. Okay, now let me draw them. What what I want, why I am spending so much time on doing all this decoration is not because that drawing a straight line I can draw them better if I go for freehand, but freehand drawing may not preserve that geometric nature what I want desperately. Now, what is the case? That let us draw a shorter eye. I should not be so. So this much is what? This is your beta. This is what? Delta. This is what? Theta. This is your V. This is IR. Right? Now you can have your JI XL right. Now let us draw again IDXT. So IDXT will be exactly in perpendicular with this one. So this is my JIDXT. Then here we will have our JIQXQ, a line that is perpendicular to So this is j I q x q, right? Now, if you join them, this is our E naught. Well, now if we get something to join this point V with this one, just a minute. This much is your JIXL, and this whole thing we can think about, that is IZS, where ZS is your synchronous impedance, right? Uh, well, if that is the case, then let us proceed. Let us try to figure out the component of ZS, right? So what you can see here, it is very interesting thing, like this is IR. Now if you see, for each of them you can have JIXL IR, right? Now for each of them you can have a projection in such a way, like if you want to get the projection of IQRA here, what would be the value of IQRA? Like this whole thing, what we can show you, if we draw a perpendicular from this point to this E naught line, then if we draw a perpendicular, then what is this much length? This gap is your IDR, right? Similarly, here if we draw a perpendicular, then what we will get? We will get something that is pardon me, this is the direction It is IQR. Why it is IQRA, I'll explain. Just hold on a minute. Now, this is IQR. Then, when you are considering in IQ, here you will get major projection, that if you draw a perpendicular from the tip of here, this much length is how much? This is IQ X AQ. Sorry, IQ XL. So what remains here? This part is your IQ X AQ, correct? And here this part, like if we draw further a perpendicular on this IDXT line, this part is what? This part is your IDXL, and this part is your IDXAD. Correct? Now, what further we can write is that we will try to establish the relation between our synchronous impedance ZS and XD/XQ. So, what we can do is that finding out one ZS is not going to be very easy for us. So, what we can do is that we can write ZQ and ZD. What is ZQ? Let me write what I am trying to say here, that ZD is equal to R square plus our XD square is the total thing, and ZQ is equal to our R square plus XQ square. Now, keeping this in mind, what we can do is that now we can write your R, that is equal to ZD like we are trying to define two triangle. One is with this kind of things with R, here it is XD, this much is your beta D, and no, not beta D, let us define this angle, let this angle be like this is 90 minus beta, but we would like to give it a name. Let us give it a name that is angle between okay, theta d. Well, so this is our angle theta d between r and xt. Here we are having zd, and another triangle r xq and zq. Well, we are all ready. So now this we can write it like cos theta d is equal to zq cos theta q. Fine. And also we can write xd is equal to z3d sin theta d, xq is equal to zq sin theta q. Now from this figure what we can write is that this much what is this much? This is like if we take this much triangle, we will run short of color eventually. So this height is how much? This is v sine delta. So that v sine delta can be written as id. We are already, I have done something that you can relate, that is v sine delta, that is your iq xq, the total length, minus, okay, now see another line has to be drawn. So what is the length of this much? That is your ID R. So minus IDR. So we are talking about this much length. Well, now if this is the case, then let us find out what is the other half. That is your E naught minus V cos delta. V cos delta, this is very simple thing to visualize. This much length we are trying to mention. This is V cos delta. So we can write E naught minus V cos delta is equal to how much? This is equal to IDXD plus this IQR. Well, where you are having your IQ is equal to I cos beta, ID is equal to I sin beta. Now we can write that V sin delta, here we are having IQ and ID. So let us write this IQ ID like I cos beta x cube minus I sin beta r. Now this further cos beta x cube this further we can do what is like x q is equal to what? X q is equal to zq sin q theta, right? So let us write I cos beta xq is equal to zq sin god xq is equal to zq sin theta q minus I sin beta. This one is what? This one is cos theta q. So together they give I zq. What is that formula? Oh god, I forget the formula. Maybe it is giving you sin theta q minus beta. Check this. Means it is long back when I was a student and I used to do trigonometry, but now I have forgotten everything. Well, if we follow this format identically, we should get I z sin sorry, no, we need to do it. Here it is I dxt plus iqr. So it is I dxt plus iqr. So it is equal to I cos I sin beta. Xt is how much? Xt is zd sin theta d plus here what is that? It is I cosine beta zd cosine theta d. So probably it will give us a formula like I cos your actually cos is irrelevant, so beta minus theta d or theta d minus beta, mane cos theta is equal to cos of minus theta, so this order doesn't make much means difference. So oh god, now we are all set. So if we do this, basically we have this, right? And like now let us take this triangle. So we know these two. So IZS could be found out. So we can write so what you will get here is, let me check it's recording. Yeah, it's recording. So what you will get here by putting this IZQ square, let us keep I square common, ZQ square sine square theta d theta q minus beta ZQ square sine square theta q minus beta plus ZD square cos square beta minus theta d, or you can write it theta d minus beta. Well, so now if we just drop I, we have reached the end of this page. Nobody cooperates. That is the pathetic thing. Well, so what we can do is that we can get finally ZA square is equal to ZQ square sine square theta q minus beta plus cos square theta d minus beta. Here ZD square, right? So if this is the case, then what we can see that this gives us in polar form, we can get kind of like this gives us equation of elliptical shape. If you utilize a few trigonometric identity, what you will get is like ZS is equal to ZT square plus ZQ square by 2. I am doing a few step jumps because those are not at all important. What is important, that is to show you a shape, and I am going to show you that xt minus xq root under r square plus xt plus xq whole square means xq by 2 whole square into sine 2 beta minus alpha, where alpha is equal to your tan inverse half xt plus xq by r. So what you will get by doing so much mambo jumbo is that you will get the minimum and maximum value of your, here it is z square, your z square, the maximum z square you will get is like Obviously this variation will happen just because of the last term. This is only variable, otherwise rest of the things are remaining constant. So z square max will be how much? It is zd plus zq square by 2, like this part, and the other one will be actually the two extreme variation of sign. One is +1, another one is -1. So we will get ZS mean square is equal to, this will only become minus. So that is the minimum and maximum value. Now if r is sufficiently small, then r square will become more, means I have already discussed that r square will become more, means quantity that you can further ignore. So what your ZS max will, if you further get it from this equation, you will get ZS max will become, obviously the first two term will also become xd square plus xq square. So it will become xd square plus xq square by 2 minus, sorry, plus xd square minus xq square by 2. So that will give you, it is ZS max square is equal to xt square, or ZS max is equal to xt. Similarly, you will get ZS mean is equal to so few things, see, that is the beauty of the whole mathematics, that when you model physics by correct mathematical equation, they also somewhere like they goes well with your, means they go well with your physical things. They are, means you cannot have any kind of, means those mathematical equations start corroborating your physical facts. See, the maximum value you are getting xt and minimum value is xq, and it obvious that like xt is should be greater than xq. And when for like, if you think about a cylindrical rotor machine, then obviously you are having xt is equal to xq, and that makes sense. So if you are thinking about an average value of such thing, then you will get kind of like, why I just derived this there. I have taken this from the book of A.S. Langston. It is that they have done a lot of further derivation, but actually I am not much interested with those further mathematics. Why? Because that mathematics somewhat may make things unnecessarily clumsy, like they have described what inequal theory. But nowadays, if you consider modern prospect, with all the invent of our modern like means your like advance in your mathematical methods, your softwares. It is not necessary that you need to do all this mathematics by your own, but your machine is like powerful enough to simulate things for you. So I would like to drop that Doherty nickel theory, particularly for the reason because right now in our present culture it is not required. Like in your next semester, you may go through Rao-Tharvey stability criteria. Now, nowadays, nobody takes the pain to understand the proof of Rao stability criteria. I can show you the proof. It is almost 12 pages and font size is as small as 10 with line spacing, one line spacing. So you can understand that how means rigorous it was. But it is also pointless that something just because something is rigorous, you should not jump into that and try to grasp everything, try to wrap your brain around. You must be able to understand that it is not only means wrapping your brain around a complicated or means intricate mathematical manipulation. You must understand that whether you are a scientist or an engineer, whether this is at all relevant in current days or not. So what was my purpose is to show you that the maximum value is almost equivalent to your xd and the minimum value is equal to your xq. And let me just share the few image from that book of Langstrop, so I could save some of my time and save some of your time. Few things need to be drawn. That is why I had drawn them by hand. But now it is time to directly share the images from those books. So here you can see that this is the kind of variation we can expect. So here in this diagram you can see that this is that kind of variation we can have here in this diagram, that two extreme case of xt xq variation, like what you are going to get for a particular load. It is interesting that this one, like the outer circle, this one, this one, this one is indicating your maximum resistance value xd, right? And this one is indicating the minimum impedance value. That is all about like xq. And this is how our z that vary between these two extreme cases. Now the obvious question that should come in your mind that whether this ZS is variable or ZS is constant for a particular load. Think about a while that whether ZS is constant or it is like it is also oscillating between the, like we are having a oscillating kind of ZS. What is the case? You think about it. Any point how to figure out that what value we are going to get. So in order to understand that whether ZS is constant or ZS is variable, obviously if you apply a bit of common sense, you could figure it out, because ZS, if we go back to our earlier equations, things will become clearer to you. Like, what is ZS? ZS is whatever terms involved in ZS equation. If we look at that, then it is clear that ZS, these two are basically going to contribute here in your ZS, right? One is this part, another one is this one. And you can see here that these two, like, these are fixed quantity, they cannot vary, right? Xd, xq, at least whatever we have discussed, they are fixed quantity, they cannot vary. You can see here that this theta q and theta d, can they vary? Let us investigate. Obviously theta d and theta q cannot vary, because xd, xq and r, they are constant. So if they are constant, then by construction of these two triangles, they imply theta d and theta q, these two are also constant. So if theta d and theta q are constant, then what would happen? You cannot get anything like any just a minute, I'm not sure whether you can hear me or not, so let me increase the volume. Okay, so what is I'm trying to say, that these two is like theta d and theta q, they cannot, like, they cannot vary. So what remains, if you notice, that only variable thing is beta. Now what is beta? If you investigate from this diagram, beta is the total angle delta plus theta, and this theta can vary with load. So in a nutshell, what we can conclude, that for a constant load, if we keep theta constant, and then it will delta, where do I have derived some, I cannot recall, somewhere I must have derived the equation for delta. Yes, here you can see that delta is also solely depends on theta and I. So if theta and I and v, all these are constants, they are responsible for delta. So in a nutshell, what we can see, that beta is also a function of theta alone.
So if beta is a function of theta, so we can say that if we keep theta constant, then we can expect, and I constant, then we can expect a constant beta, and therefore that would ensure a constant value of zx. To understand it in a more clear way, like at which point we are going to operate, let me show you another diagram from the book of A.S. Langston, and that is also a very like illustrative one. Here you can see let me crop, otherwise cannot manage this here. Actually it should be a circle, but now it is somewhat clear. It should more be like a circle. So, unfortunately, I have taken this from someone, and this got distorted due to means. Anyway, you can understand that this one should be a circle, right? Just a minute, let me see whether we can do something with this. More or less, let us try to serve our purpose with this. We cannot have a better picture at this moment. Whatever we could, I could manage, let us try to do the job with this much. Now see here, what is the issue? It's very simple. Like, if we try to represent the variation of Zs as a function of these angles, what we can write is Zs is equal to Zd cos theta d minus beta plus j zq sine theta d minus beta. So from this geometrical interpretation, what you can see is that this line L yeah, this line OL, actually this line OL represent the term J, means that is R plus your jxt plus xq by 2, this line OL. Right, but this line you can only get when you are having your beta is equal to 0. Right, so if it is that one, now like if we consider that minus j this part, then you will get what? Then you will get another portion, like it is all about you can consider, like without going to much details. Actually I want to, okay, well, so here it is clear. Now I have done a bit background work to copy a few more equations from that book, and what we can write is that this black ink equation, what I write, that same can be represented in this using just simple Euler identity. We can represent this in this form. Now, the typical advantage of representing things in this form is that for all the part you can figure out, like when your beta is equal to 0, what this OL line will indicate. This OL line will indicate your RA or R in our term, like in the book they have written RA and we are written R. So both are equal. So this much is our R. There is no tension with R. The tension only thing is with XD and XQ. So, and of course their combination. So what is this line? This one. This is actually representing. It is actually, we are taking it in polar coordinate form. So this R plus jxd plus xq by 2 e to the power minus j beta, this whole thing, this is actually represented by your this line. Like, although I have written it, means I should not write it in this way, rather I should write it in the magnitude form, like it is something that is root under r square plus xd plus xq whole square. Right, this O to L length is this much. Well, this is the first part, and the second part, the length of the second part is this xd minus xq. So they form a triangle, and this side O to P, this O to P is your
ZS. Because what is your ZS? If you look at the equation of your ZS is principally these two component, and obviously the second two part, they are responsible for your this thing. So it is like, now if we consider a different angle, what is psi in their term, it is beta for us. So if we consider movement of beta 1 in clockwise direction, then what would happen? This OL means this one will turn in clockwise direction. Fine, there is means this part remain constant, because you can see here that it has nothing to do with your magnitude dependent part. What actually is responsible for change is that orientation of this vector, that is denoted by LP. Now here in this case LP is vertically downward, so that is why you are getting the ZS between O and P. Now when you are having your LP here for beta 1, then what would happen? The beta 1 position, LP would also rotate by an angle. This much is what? This is beta 1. And LP should rotate it in like counterclockwise direction, because it is something that is having positive J beta here. This is having minus J beta, that is why it should rotate in clockwise direction. And as this one is having plus J beta, this vector here LP, it should rotate in counterclockwise direction, because it is having a positive angle part. So once you are done, then here again you are having this side is root under r square plus xd plus xq by 2 whole square. This side is xd minus xq by 2 whole square, and this one is your ZS. Same thing will happen here when you will take another value beta 2. The first vector, this one, will again rotate further in clockwise direction, and the second one will rotate in counterclockwise, and they give you ZS. So for different value of vector, you are getting different value of ZS. So it is now the question that when you can get the maximum and minimum value of ZS. The maximum value of ZS we have already established that it is approximately equal to XT, and minimum value is approximately equal to XQ. Now how to corroborate what I was trying to tell, but then I started discussing this mathematics. How to corroborate this in physical system, and how to understand that it represents our physical problem. The issue here is very clear that, see, it is something like you are having xt. What is xt? That is direct axis armature reaction, or represent MMF, a drop across a fictitious reactance that represent a drop, MMF drop across direct axis. So it is obvious that when armature reaction MMF, both AD and AQ, they are also rotating at a synchronous speed along with your field winding. Your field winding is continuously rotating, your synchronous field winding is rotating at a synchronous speed, and your
this AD and AQ, the armature to fictitious armature reaction along, means they are not real, AD and AQ. Unlike your normal cylindrical rotor, armature reaction was single and it was a real. But what we observe for salient pole, that it is not possible for us to represent it in that way. So we have means resolved it into fictitious components, the entire MMF, armature MMF, that is AD and AQ. Now AD is armature reaction MMF along direct axis. So direct axis armature reaction MMF is facing, remember I have already mentioned that field MMF always face an even reluctance magnetic circuit, but armature AD that always experience armature circuit with smaller reluctance. So as it is facing smaller reluctance, it will offer a predominating demagnetizing or magnetizing whatever action, armature reaction will be predominating, because it is the reluctance of that particular path along your direct axis is very small. While if you consider AQ, the reluctance observed or experienced by AQ is quite high. So the corresponding XQ becomes smaller than that of XD. Once again, AD experiences a reluctance that is quite smaller than that of experienced by AQ. Direct axis armature reaction reluctance is very small in comparison with quadrature axis armature reluctance, and that is why it is obvious that direct axis armature means the direct axis armature reaction will be predominant in comparison with quadrature axis armature reaction, and that is why you will always have XD greater than XC. The two extreme cases you will have, one is when XD ZS is equal to XT, another one is ZS is equal to XQ. Now the last question in this regard is that what value of beta that gives you maximum ZS. So in order to answer that, what you need to check is that this Phasor diagram. Here, what is your ZS? This is your ZS. Now, or that ellipse, what is this ellipse? This point where your ellipse meet your pink color XT circle. So when you get this much, think about it, and next day I would like to hear from you that when ZS will become XT and when ZS will become XQ. For which, particularly for which value of beta. So even you can figure out the answer from this diagram also. Here you can see that your task is to make sure that well 1, if you can somehow, if this is your OL and this one is your then this will become your maximum value of. So at this, what is the value you need? Think about it. What value of beta would give you this much angle? And what when it will be minimum? When this beta will be like just in somewhere here, then it will become minimum, right? So think about it and let me know your answer, that when it will become maximum and when it will become minimum. In our next video we will discuss test and then we'll go for numerical